All right, we're going to start on Unit 2 here. Unit 2 is all about equations. So this is obviously a lot of the stuff that we anticipate using when we talk about algebra in general. A lot of this will definitely be review from things you've seen before, but then some of it's going to incorporate some of the new topics that we've talked about in Unit 0 and then also in Unit 1. So let's start off with some vocab. First word here is a solution. That's just a number that yields a true statement when substituted for the variable. Once we get into quadratics the next couple weeks, we'll also call those roots or zeros. Now, an interesting thing to talk about when we say solving. When we solve, that means we need to find all of the solutions. That's really important because if you just get one answer, one solution that's true, like we use that above definition, there could be other solutions. So we'll talk about that, what types of problems might give us more than one solution we need to focus on. And then the last thing is an equivalent equation. Now, an equivalent equation is just something that has the exact same solution. So I'm going to focus on the one on the right side. Obviously, x on this one, x is going to equal 3. If I plug x equals 3 into this equation, 2 times 3 plus 1 is equal to 7. Now, I could also write this equation as 2x equals 7 minus 1. Now again, if we plug x equals 3 in there, 2 times 3, that's 6 on the left side, and then 7 minus 1, that's also 6, so it is a true statement. We could also write it as 2x equals 6, and we could also write it as x equals 3. So we can take x, or we can take 3 and put it into any of these four equations and get it to be a true statement. So if you'll notice, I basically went through the steps to solve this equation for x. And the idea of equivalent equations, that's why we're actually able to do all the opposite operations and things that we're able to do to solve an equation. All right, so let's start off pretty easy. Again, not trying to insult our intelligence here, but just so that we're all on the same page. We're going to solve this two-step equation here. We want to do opposite operations. We want to get the variables together and then everything that does not have a variable attached to it on the other side of the equal sign. So I'm going to subtract 2x first from both sides. When we subtract it over here, we get 0, so I'm going to go ahead and cross that out. I get 4x minus 7 equals 5. Now, my variables are all on the left side together. I want to get the constants to the other side. Again, that's gone. 4x equals 12. 4 times x is multiplication, so our opposite operation is to divide, and we get an answer of x equals 3. Now, especially with these equations as we get going, you definitely need to show your work, but the amount of work that you show kind of differs. For example, on this one, I would be okay if you subtracted 2x from both sides and added 7 in the same step, and then just kind of jump down to 4x equals 12. But obviously, the more work you can show, the better off you're going to keep track of stuff, and then if you do happen to get a wrong answer, I can give you some partial credit. All right, another type of equation. When you first come across this problem, it looks like we need to FOIL. So we're going to go ahead and FOIL this out, multiply it out. Now we first see that we get some x squareds, which leads us to think this could be a quadratic. But if we keep going, let's see what happens. So we'll simplify each side. And you might notice it already, but you should see that there's a 24x squared on both sides. Now, a lot of times we'll just cross those off because it shows up on both sides. But remember, the real reason we can do that is because we're going to subtract 24x from that side, and that's 0. We have to do the same thing to the other side, and actually, that's 0x squared also, which is 0. So that's why a lot of times if you see the exact same thing on both sides of the equation, we just end up crossing it off, and I'm okay with that. So again, now we're just at a two-step equation like before. I'm going to get my variables to the left side, get my constants to the right side. Again, I'm going to kind of do this in one step. So I'm going to get 12x equals 5, divide by 12, and this one ends up being a fraction. Please get in the habit, guys, of keeping stuff as fractions. Obviously, if they're reduced, that's even better. Improper fractions are okay, and I prefer improper fractions over mixed numbers. I really don't want decimals. There's a bunch of different reasons. We can start using these answers on other types of problems and the decimals might throw it off. The only real time that I want a decimal answer is probably with an applied problem, with a story type of problem, because that makes a little bit more sense to report it back that way. All right, with rational expressions. So this combines what we just finished up this past week with now solving equations. So again, we're going to find the least common denominator, which we practiced that a lot last week. Then what we need to watch out for, we can't have 0 in the denominator. So we're going to take any of those LCD parts, set them equal to 0, and then these are not solutions. Okay, we're just going to keep those off to the side and come back to that at the end, but those cannot be answers. We're going to multiply each term by that same thing, top and bottom, and then actually, as long as you have that LCD, you can ignore the denominator. So just like we did before, but this time the denominator's pretty much all gone. We're going to solve it, and then we have to make sure we go back and check our solutions. If anything was sort of told that it can't be an answer from number 2, those are called extraneous solutions. All right, so here's our example. I'm going to look for some denominators. I see x minus 2. So I'm going to solve that equation. So this means that x cannot equal 2. And then that's actually the only denominator we have. Now what this tells us is x, we don't really know yet. X could be any number in the whole wide world except 2. X cannot be 2 because our denominator would be equal to 0, and then that fraction would be undefined. Now we're going to go back to last week and just get all of our denominators to be the same. Actually, I'm going to change this to 1 over 1. Remember, any constant or anything by itself is really just something over 1. And then let's see, I'm going to find my denominators. My common denominator is just x minus 2, and this is the only piece that needs an x minus 2. So each part of the fraction has that x minus 2. So now I'm actually able to ignore it for the rest of the problem. Once we get here, this should look a lot like stuff that we solved in Algebra 1. So then 3x equals x minus 8. Get all the x's together, divide by 2, and oh, sorry, that's not correct. I switched the order here. And then we'll FOIL on the other side. I see a 12x squared. I'm going to go ahead and cross those off because they would subtract out to 0. I'm going to combine my like terms. Get all the variables on one side, get the constant on the other side, and we get kind of a weird fraction on this one. So negative 3 over 61 is our answer. We do need to check to make sure that our denominators don't equal 0. So 6x minus 2, set that equal to 0. We get 6x equals 2. So in this case, x cannot equal 1/3. And then over here, for our other denominator, x cannot equal 13 over 4, which is not the case in this one, so we are okay to go here. All right, the last thing is just another way that we're going to solve equations, but this time we're going to solve for certain variables. So in this one, we're trying to get the f by itself. Now, one thing we're going to work a lot with fractions, we're going to multiply by the reciprocal. Okay. Once we multiply by the reciprocal on both sides, right? On the right side, the 9's divide out, the 5's divide out, and so that's why this is a really, really helpful tool here. And so now we're just left with f minus 32. And I would rather you multiply both sides by that reciprocal instead of distributing, just because it makes the problem a whole lot easier. And there's our answer for that one. So all we're trying to do is to get the f by itself. Now we're going to go through one more example real fast. I didn't put this in the notes, but I want this one to be solved for R1. This does have our least common denominator stuff going on. So let's see, this guy's missing an R1 and R2. This guy's missing an R and an R2. And then this one is missing an R and an R1. Now again, as long as all of our denominators are the same, we can go ahead and ignore them. So we're just going to get R1. And again, this is a physics equation, so I have not taught or taken a whole lot of physics. But if you have, you might know what this equation's looking for. Now I'm trying to get R1 by itself. So I need to subtract this whole thing to the other side. And then, because I see that this has an R1, basically this is a GCF. So that's what's going to happen with a lot of these problems, is we're going to see a GCF. And now, sorry, I'm kind of running out of room, but I'm going to go ahead and divide to get that R1 by itself. And then here is our answer. So a lot of times these little equations end up being kind of tough equations just because they use a lot of algebra. But it's definitely something we're going to practice with and use quite a bit. So that is it for this section. This is 2.1 equations. So have a great rest of the day.